event is an event that has happened several times at the museum in the past, and it is an opportunity for our behind-the-scenes experts, some of our researchers and some of our specialists that deal with the maintenance of our collection, to interact with the public.
Hi, my name is Alex Tirabasso. I'm a 3D production specialist at the Canadian Museum of Nature. And what I do is I use computer graphics with 3D animation to visualize science, to make entertaining graphics, and to communicate complex scientific stories for Canadians.
So how do you get it to work 3D? You have to, I'm guessing, scan the fossils.
Yeah, well, you have to scan the fossils first. That's done in our lab in the Canadian Museum of Nature. It comes to us, and then a laser literally scans it, and then we have these digital files that we handle and process to create the 3D model.
And I knew that we had this 3D center. It wasn't until he was here at the Meet the Experts event that I really appreciated what incredible skill and background he brings to his work and to the value here at the museum.
I think growing up, I wanted to be more of a scientist, whether get into biology or biochemistry. I love plants, I think I liked science too much, too many facets of it, and I couldn't really focus down on one thing, whereas getting into sort of scientific animations and scientific communication allowed me to kind of have the best of all sciences and be able to work with all the professionals. This is the skull, the reconstructed 3D virtual skull of Pohila darwini. Pohila darwini is a recently discovered 20 million year old animal up in the Arctic of Canada. These darker regions here that we see, these were the actual fossils found in the Arctic, fragmented, broken up like an eggshell, scattered all over the sand. And what we did is we scanned it in 3D and virtually put it together like a puzzle, put it all back together using the 3D software. That 3D print, a physical replica of that Pohila darwini skeleton, is a derivative. It literally came from this 3D model. So we built the 3D model virtually, reconstructed it, and because of that we were able to create something called a 3D print, a clone of this creature, so that it could be used in exhibitions, physical display. People can see it in a realistic setting. Once you have it in 3D, once you have this 3D graphic, you sort of have it, I like to say, in an eternal state, because it is a permanent model. And from there you can do so many things with it. The 3D graphics that you have now will be 3D graphics that you have 10, 20, 30 years from now.
If children have an interest in something in particular, then they're able to meet somebody who studies that and learn that there is career potentials. There are real jobs for people who want to study paleontology. I know when I was a child, my only career ideas were possibilities that I had been exposed to. So you don't know what's possible until you meet people who do these things.
My name's Danielle Fraser. I'm doing my PhD at Carleton University. And what I'm really looking at is the relationship between the number of species, the climate, and their diet. So I look at different fossil organisms and I try to figure out what they're eating. This is the moose. So moose generally eat a lot of tree leaves. Moose are a little bit weird. They also feed on some aquatic vegetation. So what they'll do is they'll eat things like lily pads. I actually find people are really interested in just what's the difference between a horse tooth and what's the difference between a moose tooth, and how can you tell what they're eating. And I just find it amazing that even like a 2-year-old is really interested in seeing that kind of thing, because I think it's because they can tie it back to having seen a horse in the past or having seen a moose in the past. So what I also do is I look for chemical signatures in the teeth. So that's called isotope testing. And so from that we can actually tell what type of grass they're eating or what type of leaf they're eating. So what we're actually testing is what did that animal, what were the chemicals brought into the hard tissues.
That's interesting.
You can also get an idea of temperature from that.
Okay.
So we do the oxygen isotopes that'll tell us how warm or cool it was during development for that animal. But I have done some work also just looking at different skulls. So if you put the horse skull together, you can see that the horse skull looks very different from something like a deer skull.
Oh, yeah.
So one thing here is that there's this big chewing muscle, you can see here, that the horse has. It's just absolutely massive. And compare that to a deer, there's not as much area being taken up by this muscle here.
Right.
And what that allows is the horse to sort of grind and chew side to side with its lower jaw.
Okay.
And so you can actually look through horse evolution and see that getting bigger.
We can read books, you can read the exhibits, but when you actually have a real person in front of you who can tell you things you didn't even know you wanted to know, what an incredible opportunity.
It's a portable solar panel that we bring with us, and that is used to charge up our camera batteries. We take lots of pictures when we're up in the Arctic of the plant life that's up there, and so we need to be able to charge up our batteries.
I think Roger Bull is technically he's a DNA specialist, but I think his master's degree was looking at bobcats, at evolution of bobcats and DNA differences. But then he started working with our botanists and he did a few field trips to the Arctic, looking at trying to do some sampling of plant populations and looking at the differences between populations. And he's hooked now.
So what do you actually do? Yeah.
So what we do in the Arctic, there's a team of botanists from the Canadian Museum of Nature, and we go up there. It's usually a team of 4 to 6 people, and we spend about a month, 4 to 6 weeks up in the Arctic, and we collect all the plants that we can find within a certain area. And this is really important baseline information for us to have, because the Arctic is a place of a changing climate right now. Things are changing, things are getting warmer, and so we're expecting to see changes in the plant communities as well. And so it's important for us to right now get a baseline sense of the plant communities so that we can assess that change going on in the future.
I think when you are so immersed in and focused on a research project, you perhaps forget of why it's important to the general public. And when you have a young, keen person in front of you who wants to know more about what you do, it also is affirming to our researchers and our specialists.
There's a plant press. Okay, so we have layers and layers of cardboard, and then in here there's plants that we flatten between sheets of paper. And then we put this out on the tundra. Hopefully it's a sunny, windy day. And then the wind in the air travels through the cardboard and dries out those plants. So then once those plants are all dry, then we bring them back to a research and collections building.
Adults too have curiosity, but children are a wonderful icebreaker, that children can start asking questions that maybe the adults thought about but didn't ask, and having access to the expert right beside you to be able to ask those questions it's so unique, and it's such a great way to, I think, inspire people to be curious.
Do you study fossils?
Do I study fossils? No, I don't study fossils, but some other people.
Have you ever seen any fossils when you go up?
Have I ever seen any fossils? Sometimes we do see interesting things. Once I found a little arrowhead, which would have been an ancient Inuit
So you
arrowhead.
haven't saw any bones of things up in the ice age?
Ice Age bones? No, not so much Ice Age bones. Often I do see bones of species that still live in the Arctic, like muskox and caribou.
You haven't saw any bones of woolly mammoth?
Woolly mammoth? No, I've never seen a woolly mammoth bone up in the Arctic. Sure. So I get to both work in the DNA lab, I get to come here to the downtown building and interact with the public. I get to go up to the Arctic and do research there. It's just a fascinating combination of so many different things. So I'm going to give you guys my Meet the Experts trading card. Okay, this is my very own trading card.
The trading cards that we developed were really to showcase the specialists and the expertise in their research, and to bring highlight to it. We celebrate our athletes, but we often don't celebrate our scientists. And an athlete, of course, takes years to develop their skills. Our researchers, it's their whole life. They can't just turn it on because somebody wants them to study ants. It's a whole career invested in studying what they study. So we really wanted to celebrate those people and celebrate the skills that they have.
So it's one of my favorite weekends to be here because there's so many kids who are just really interested to meet you and ask all kinds of questions about the work that you do.
In terms of thinking about why should we be interested in science, when you meet people who dedicate their life to it, you get a different perspective on what motivates them, what keeps them excited about what they're learning and what they do. And hopefully that excitement is contagious for people to come here, but also then when they're exploring the natural world, be more observant and have more questions, and hopefully within themselves know that they have the capacity to find answers to their questions.